Hi, welcome to my projectbuzzer.com. Now we are going to see the process of optimal distributed malware defense in mobile networks with heterogeneous devices. Let's move to abstract. As malware attacks become more frequently in mobile networks, so to deploying an efficient defense system to protect against infection and to help the infected nodes to recover, it's important to prevent serious spreading and outbreaks from malware nodes to optimally distribute the content-based signatures of malware, which helps to detect the corresponding malware and disable further propagation. To minimize the number of infected nodes, mobile malware can propagate through two different dominant approaches, such as MMS and proximity malware. MMS approach: a malware may send a copy of itself to all devices whose numbers are found in the address book of the infected handset. Designing a defense system for both MMS and proximity malware based on the framework of optimizing the system welfare utility, which is the weighted summation of individual utility depending on the final number of infected nodes through the signature allocation. An optimal distributed solution to efficiently avoid malware spreading and to help infected nodes to recover. Our goal is to minimize the malware infected nodes in the system by appropriately allocating the limited storage with the consideration of different types of malware. Let's move to see the DFT process. Create a mobile networks including a number of nodes. First define number of nodes and also define source node and destination node. The network contains heterogeneous devices as nodes. Mobile nodes are more efficient to disseminate content and information in the network. Helper nodes are referred to as special nodes. These nodes is easy to focus in the all nodes. File can be transmitted from source node to destination node through the help of helpers node. At the same time, special node of a helper node generates the signatures. These signatures are content-based signatures using greedy algorithm for generate the signature file and key file for the related content. All intermediate nodes receive a content-based signatures. These signatures distributed for every intermediate node from source node to destination node with the help of the special node. Using GTN model to analyzing the malware nodes through pausing the signatures. Apply $1 network technique to identify the malware nodes in the mobile networks. Apply Metropolis sampler technique is easy to encountering the malware. Detect the malware with the help of a content-based signatures. Exponential parameter update from the contact records between helpers and general nodes. Every intermediate node receives the signature from helper node and which intermediate node receiving signatures twice. This time to detecting the malware spreading node and recovering the infected nodes. Contact trace simulate the malware spreading and compare the simulation results of infected ratio with an update by the model. For proximity malware propagation, we use both realistic mobility trace and synthetic trace for simulations. Determining the malware spreading time and malware recovering time will be calculated using the signatures received traces. Let's move to see the project demo. Malware as a project name. This name same as a package name malware. This package contains all the frames in our project. Home.java is the first frame of our project. Select frame and right click to run file. The frame will be loaded. Click here. This frame is used for creation of nodes. Click node formations and enter the number of nodes count 15 and OK. Message will be displayed. Node created successfully. Node 15 nodes will be generated in the list box, and these two combo boxes are used to display the source node and destination node. First select the source node and second combo box to select the destination node and click data storage. These informations will be stored into the database. and click next to show data. These details will be displayed here. Click to next. This frame is used for a helper creation. Create helper and enter the counting of numbers of helper creation 5 and click OK. Helper node created successfully message will be displayed. Click OK. Helpers node will be displayed. And click insert nodes. This nodes details will be stored into the database. And click view node properties. All node details will be displayed here in the table. And click to next. And this frame is used for evaluating the intermediate nodes. Click evaluate intermediate nodes. Intermediate nodes successfully evaluated message will be displayed. And click insert to DB. All intermediate nodes insert into the database. OK. And retrieve nodes. These intermediate nodes are retrieved from database. These are the intermediate nodes. Click next. This is the node evaluation process. Get SN, source nodes can be retrieved. Get DN, destination node can be retrieved. Get helpers, helper node will be retrieved. OK. And select a helper. And select anyone approach. And click data storage. Data stored successfully message will be displayed. Click OK. And click next. This frame will be used to selecting the transfer file content. Click select file and click source and click image and click sample.txt. File path will be generated here. And click find points. Details will be displayed. And click file contents. File contents will be displayed. Click next. Apply greedy algorithm. File signature generated message will be displayed. And click contact tracers. Nodes details will be displayed here. Source node, destination node, helper node and approach, and these are the intermediate nodes. Click signature file. These are the signature file content. And click send. Signature file will be sent to the nodes. OK. And next to click spread.java and to select run file. Next to click receive. Signature received. Sample.txt is a file name and signature.txt is a signature file name. Key.txt is a key file name. Click check nodes. All intermediate nodes will be retrieved here. Select node and click apply TTN. Apply TTN is used to analyzing the malware nodes. To select every intermediate nodes in the checklist and click apply TTN. TTN as a delay tolerant network model is used to analyzing the all malware nodes. And click malware list. All malware nodes will be encountered successfully. Click next. Click final traces. These are node details informations. Source node, destination node, helper node and approach, and self intermediate nodes. These are the intermediate nodes. Click add file. Destination is file successfully. Click file content. File content will be displayed. And finally click performance. These are the malware spreading rate and these are the malware recovery rate. Thank you.